Hey there, welcome back to the channel. Just take a look at this horrible code. Like, I know it's my code. I've written it for like a couple of episodes now, and it's horrible. So we are going to write better code now. Like we are going to, you can say, refactor most of the code. So let's call it header block. Yeah, it will have a size t value, size, then it should have a pointer. So header block next and struct header block previous. And then I don't think we need anything other than that. Yeah, we'll make another struct for footer. So yeah, just header block. So type def struct footer block, and it is just size resize footer block. Yeah, sorry. And let's say we have uh, header as size of header block, not this. Boom, 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 footer. Okay, let's change this one too. So this is a header block, it points to null. Let's change the traverse function. Yeah, so void function, um, yeah. So the same thing, so traverse free list. This will actually be not a void pointer, but yeah, header block pointer to pointer, free pointer. Yeah, not void. Um, header block pointer. Let's call this same thing. Sorry. So while current is not equal to null, when current is not equal to null, what are we going to do? We are going to what was it? Check the size, right? Yeah. If the current block has a size that is, if current size is greater than or equal to requested size, that means it is an appropriate block that we need to send back. But also we have to check one thing, which is like if current previous is equal to null. What does that mean? So since we are going to utilize that free block, we have to remove it from the free list. So for doing that, we have to change like the structure of the free list. Like the first block should skip the second block and directly point the third block. And third block's previous pointer should directly point to the first block. So we are checking over here that if the appropriate block, we are checking that if the appropriate block that we found is the first one itself. So if it's the first one, then it's pretty easy. We just say like the three pointer should be equal to current next, and well now it's pointing to current next, and we'll also check another thing, which is if current next is equal to null is not equal to null. Let's do it. Yeah, it's not equal to null. If the next block is not equal to null, then current's next previous should be equal to null. Yeah. So the next block's previous pointer should be equal to null. Yep. Cool. And if current previous is equal to null. Yeah, this is cool. So now let's go into else. So let me just check one thing over here. Sorry. So yeah. previous pointer of the next block, we compare the size, then we go over here, we change the pointer, like the free pointer now points to this, and the previous pointer points to this, the current blocks next, sorry, yep, cool. And then inside else, which is the current, the next block is equal to null. Well, we don't do anything in that case. Duh. We do have to do some changes inside this, which is the next pointer of the previous block, the next pointer of the previous block. Which one was it? So we are inside size, and if current previous is equal to null. Yeah, let's add this over here. So now we know that the block is the middle. So now, yeah, let's so current blocks next, current blocks previous blocks next pointer should now directly point to current blocks next. Cool. And then if current next is not equal to null, then current blocks, the next block's previous pointer should now be equal to current blocks previous, right? Yeah, sorry. So I guess this is it. And if we don't find anything, so if this is, so in this else condition, current is equal to current next, right? And here we'll just return null. Cool. See, that was so easy. And this is such headache. Look at this awful code. Oh boy. Oh, it's a horrible code. It's not at all readable. Okay, so now our traverse playlist. Wow, 7 minutes 45 minutes in, sorry, 7 minutes 45 seconds in, and we have completed a function. That's cool. So we don't need this function anymore, right? Let's comment this out. Let's go inside my mallet and let's write our own my mallet. Let's write it above itself. Boy, I haven't been speaking for so long. It's fine. It's fine. No one even watches this much video. Most of the people only watch like first uh, 30 seconds, 45 seconds, whatever. So let's say we have a block over here. So this is the header, this is the footer, and then there's another block. So let's say this is the block that we found. So our process wanted some memory, and we found this appropriate block. Well, we can't just allocate this entire block, right? Let's say process wanted 5 bytes, and this is a block of 500 bytes. We cannot allocate this entire 500 bytes to this process because it just wants 5 bytes. That's like really, really small. Instead, what we can do is that we can split this block like this, where this will be the header, this will be the footer, this will be, let's say, the aligned size. So this is its aligned size is 8 bytes. And let's say we allocate this 8 bytes, this is header footer, and then the remaining bytes become their own, its own free block. Sorry, but the thing is that this block, so this block can only be created. So this splitting can only happen only and only if the remaining portion of the block is at least header plus footer. Because the smallest free block looks like this. Sorry, the smallest free block looks like this, where it has a header and a footer and no space, right? So that's what we have to add a conditional. Like the minimum space left should be at least header plus footer, and if it's not, we can just allocate the rest of the space to it. So okay, sorry, I'm really sorry. I'm not feeling well for past few days now, but okay, no problem. So yeah, over here, what was I going to do? Yeah, let's get the size. So so I get a free block, right? Yeah, cool. So free block, yeah. So allocated block size, or should I just write block size is equal to free block size, cool. And if what should I say? If block size minus align size is greater than or equal to. So block size, let's consider 500, 500 minus 8. If it's greater than or equal to at least header plus footer, that is the least thing that we want. So let's say here we find like the block difference, whatever the space left is not header plus footer. So that means we can just allocate the entire space to it. So that's what we will do. We will just allocate, sorry. So this just means we can allocate the entire space to it. So yeah, we just return, you can say the thing to it, which is so free block. Yeah, so we have free block. So I will return, is that space? Yeah, that's not space. Yeah, yeah, cool. So void space is equal to void pointer, char pointer, free block. Yeah, why did I call it next new block? Yeah, I should call it new block itself. Yeah, cool. Yeah, okay. And yep, so free block plus header, boom, return. And then return space. And if it is greater, then we have to split it. And then we have to allocate the newly created block to the newly split block. So let me show you what I mean. So now when we allocate header and footer to it, so when we allocate header and footer to it, am I audible? Yeah. So let's say block size. So block size minus align size greater than header plus footer. Okay, so what should we do now? Let me look at the previous code. That will give me some idea. So yeah, size difference is minimum space. Header allocated, footer allocated. We change the values of it. Block space is this. We change the values for that. Yeah, yeah, yeah. So yeah, size t. Let's call it size t. So size t new block, or should I say split block? Split block, split size. Total split is equal to uh, what will total split? It will be what was it? Header plus footer. This merged align. So the total space, which is block size minus aligned. Yeah, cool. Sorry. So the total split is block size, which is this. So the entire block size minus align size. From that, boom, footer moved forward, and the rest of the space is left over there. Yeah, cool. And size t useful space is equal to total split minus header minus footer. Cool. Yeah. One more thing, we have to like make a structure, right? So we have to change the values for header and footer. Cool. So let's do it. So we'll cast that into the new one, which is so header block pointer. So not split, but allocated header. Yeah, allocated header is equal to um, allocated header is equal to header block pointer, header block free block, right? We get a we get to it. So header block, we cast that into it. We already have free block, right? So we got free block. We do it from the start code. We can directly change the values of the free block. Now let's keep it like this. So allocated header, yeah, cool. So allocated header, the size value inside it should now be a line size because only we are only utilizing that much. So also allocated headers. So next should be null, cool, and also previous should be null. So that's cool. What does the structure for the block look like? Yep. And yeah, I could have done that. Okay, so now we have set this. Let's change header block allocated footer is equal to header block char pointer free block plus we move forward by header plus align size cool and now allocated footer the size value is also equal to align size. Cool. And now the split block. So header block split header is equal to header block. Uh, what should it be? Allocated footer, right? Yeah, okay. Allocated footer, and then we move forward by footer. So now we are at the start of the split block, and then header block split footer is actually split header. So we have over here, we move forward by header plus the useful space. Yep, cool. And then we change the values. Boom. Split header, size value for it will change to useful space. Also, split footer size should also be useful space. Next should be the value inside what do you call? Sorry. So this should be three pointer next. Cool. And split header previous should be null by default. Yeah. Also, mm, also I have to change like yeah. So if three pointer next, if it's not equal to null, then I have to change its previous values. So three pointers next blocks previous value should now be equal to split header, right? Cool, cool. Yep, I think it's done. Wow, we wrote so much code in just mm, crazy. That is crazy. And if there was an error, so if we didn't find anything, yeah, is that it? So if and then another if condition over here, and then there's else, and then there's return. Yeah, cool. So now we will return. Yeah, we have return space over here. We'll just return also. We'll also return over here. So split block is added, and then we'll return. What was it? Allocated header, right? Yeah, allocated header plus header. Yeah, yeah, cool, cool, cool. So allocated space is equal to passing into void char pointer allocated header. Okay, yeah, cool. Yeah, and allocated header plus header. Yep, that's correct. Then we return the allocated space. Cool. I just can't wonder how productive I am right now. Right, 30 minutes in, and we already have like a working my malloc function. That is really cool. I can just get rid of this entire code. Yep. Sorry. So yeah, okay. So much code that we don't want right now. So we have to like code for coalescing R and L and then my free, right? Yeah, let's get working. It's going to take a lot of time. So void, yeah, my free, got a void pointer, that's cool. And then we don't want to copy. Yeah, get this function is cool. So we'll keep this, but just I don't know left full block. Yeah, let's do some changes to left full block. Or over here. Yeah, bool left, sorry, bool left full block, void pointer. So it takes in a void pointer and tells. So now we get over here, right? So if you cast that into header, you have to check the left free. You have to check like if the yeah move back by footer. Yeah, yeah, that's good. That's good. So size T left block size. I'll just write left block size T. Yeah. Cool. So left block size is equal to, let's cast that into header block or footer block, right? Since it's the left, we are checking the left side. Yeah, it is called footer block, right? Yeah, yeah, cool, cool. Yeah, so cast that into footer block pointer, char pointer, whatever the pointer we get, we move behind by footer. That's cool. And then check. So if left block size, yeah, I'll change that afterwards. If it is, then we'll return false. And if it is not, then we'll return true. Yep, cool. And then the same thing for the right three block. So point, pointer, pointer. Yeah, yeah. So header block, right block is equal to, yeah, header block, char pointer, pointer plus header plus. Well, what is the current block size? You have to get the current block size for this. Yeah, let's cast our block. So header pointer. Hmm. And then size t current block size is equal to current block. Hmm. So we move forward by current block size, or I should say block size, and this should be current. Yeah, so block size, and then we cast it into header block. Yeah. So if right block size mod 2 equal to 1, that means it's allocated, so we'll return false, and if not, we'll return true. Cool. And this is commented out. Cool, cool, cool. Let's also, what is, yeah, skip block, yeah. So we will, here we get these things. So what is new block pointer? Yeah, cool, listen. Oh, this will take time. This will take a bit of time. I think we should end it over here. 37 minutes in, that's cool. Uh, we did a lot of things in this, uh, like git status. So diff. Yeah, that's like 75 line changes. So that's cool. Sorry. That this is a good day. We can consider this as a good day. Yep, a lot of changes. I think we should stop it right over here. We did a lot of things. And in the next video, we'll also complete the coalescing part. Uh, I guess that is it. I'm Aditya Pachorni, and I'm in the GM for fun. Bye.